Hello, my name is Ashish. I'm a PhD student at Georgia Tech. I'm presenting my work on improving the performance of user file systems. User file systems offer better security and system reliability. They are easy to develop, debug, and maintain. However, they perform poorly. Fuse is the state-of-the-art framework for developing user file systems. Over 100 file systems have been written using Fuse. Under Fuse, all file system requests are served in user space. We evaluate performance of Fuse using Linux compilation workload. Despite all optimization, Fuse reports a high overhead compared to ext4. The main cause of performance overhead is context switching and data copying that occurs while serving file system requests in user space. As seen from chart, we see a lot of context switches to user space for kernel compilation workload. Therefore, if we reduce the number of context switches to user space under Fuse, we can improve its performance. This is exactly what we do in this work leveraging eBPF framework. eBPF allows applications to insert custom code in the kernel and safely execute them under a virtual machine runtime. eBPF is a part of the Linux kernel and is used by perf, tracing, and networking subsystems. We integrate eBPF with Fuse to provide extFuse framework for user file systems. Under extFuse, developers can insert custom code in the kernel and serve file system requests right in the kernel without incurring any context switches to user space. We consider the same kernel compilation workload for evaluating extFuse performance. As seen from the graph, it performs at par with ext4, and this is because now fewer requests are now delivered to the user space. Since extFuse allows custom code to be safely executed into the kernel, it opens up a number of opportunities for optimizations. Please refer to our paper for details. Thank you.